I would like to introduce Roberto Salgado, who will give you a wonderful talk on obfuscation.
Hello everyone, it's great to be here. It's really exciting to be facing that way for once instead of the other way around. I have some really interesting stuff that I'm sure you guys will love, of neat techniques on optimization and obfuscation. There's a lot of stuff to go through, so I'll jump right into it. I'll just introduce myself quickly. Of course, my name is Roberto Salgado. I'm with WebSec. We're an information security company that provides security solutions through security auditing, testing, training, and monitoring. I'm the creator of that SQL Injection knowledge base, which some of you might have heard of. It's a really complete resource for SQL Injections, has everything you need to know. Recently, I've started programming with Python, so I'm considering myself a Pythonista now. I recently wrote a tool called Leapfrog, Panoptic with Miroslav Stampar from SQL Map, and it's a pretty cool tool if you haven't heard of it. It just helps find configuration and password files through local file inclusion type vulnerabilities. Quick overview of what we will be seeing is we'll talk about different blind SQL injection methods, which allow us to retrieve data faster from the database. We'll see some optimized queries. And then for obfuscation, we'll talk about a bit of fuzzers, encodings, and how we can use that to bypass firewalls as well. And hopefully, if I have time, I can show you Leapfrog, which is the tool that I've been developing to help audit firewalls and try and make them more secure. So I know this comic is in like 90% of the SQL injection talks, but since my name is Roberto, I thought it was pretty fitting for me, so I decided to use it. This is my only defensive slide. BobbyTables.com is a great resource that shows you how to protect in almost every language against SQL injections. I once had a client that told me he fixed his SQL injections by implementing SSL. So for anyone who thinks like that, please visit that website. Starting with optimization. So why would we care? Why would we want to optimize our queries? Essentially, by optimizing our queries, first of all, the most important thing is we can extract information from the database much faster. Not only that, but it will reduce network congestion, bandwidth, much lower probability of being detected, and there are several other reasons why we should be interested in optimizing our queries. So some of the methods we'll be analyzing is the traditional bisection method. This is the most common method when extracting information from a database through a blind SQL injection. The bisection method is also known as the binary search algorithm for computer scientists out there. So it's essentially the same thing. We'll look at a regex method, some bitwise operator methods, and finally a method that I invented, which I like to call binary to position. So just a quick reminder, it's very important to remember most of the time with blind SQL injections we can only retrieve one character at a time. That's why it's most important to optimize blind SQL injections and other types of injections. Before we dive into the methods, just a quick overview of the ASCII table to help you understand these methods. ASCII essentially stands for American Standard Code for Information Interchange, and it was invented because computers can only understand numbers, so we needed a way to represent different characters and letters. Here you can see the different representations, octal, binary, decimal, hexadecimal. This is kind of what the ASCII table looks like. It's just have different representations for each characters and such. An important thing to remember when optimizing queries, and you'll see this later in these methods, is that for the range we're interested in is usually code point 32 to 126. And through that code point and that range of 94 characters, the leading bit will always be 0. So how does the binary search method work? I'll just go through it quickly because this is a known method. but it's important to understand when comparing it to the other methods. Essentially, we take our ASCII range, 32 to 126, we split it in half, and then we search if the value is greater, that we're searching for is greater or smaller. And then we, depending on what branch it is, we'll split that in half again and repeat. It's a divide and conquer type algorithm, and it's very effective. It's kind of what it looks like in action. So a little graph of how we split the set in half and then check each side. So the pros of the binary section is that it's very effective and it's very easy to implement. It usually has around 6 or 7 requests per character. One of the cons about it is that it's the best case scenario is kind of the same as its worst, as its average and worst case. It doesn't vary much. So for our next method, we'll see the rejix method by Root ATI and White Sheep. This essentially is an adaptation of the binary search algorithm by using regular expressions. So essentially, it has the same pros and cons as the binary search. It's just a different implementation of it. For the bitwise methods, there's several bitwise methods that we can use using different bitwise operators. The first one we'll be seeing quickly is faster. Jomer Dehen wrote a paper, Faster Blind MySQL Injections, using bit shifting. But his implementation was a little weird because he starts off by comparing 1 bit at a time, but later he starts comparing 2 bits at a time, and that's not good because it doesn't allow us to implement threading since the next request will rely on the previous request. One thing about the bitwise methods is that it will always be 7 requests per character because what we're doing is retrieving the binary for each character, and the binary will be 7 digits. Here's a little variation I created of the bit shifting method. Essentially, we just shift the character by each number, and then we can retrieve the last position. And that will give us the full character we're after. So for example, A is 97 decimal, and that's the binary sequence for it right there. So that's kind of how we could implement that method there to retrieve these characters. All the bitwise methods have the same pros and cons. There's another bitwise method that uses anding instead of shifting, and it was by Ruben Ventura. Essentially, we and the first, second, third, and fourth, and that essentially starts giving us the characters there that we're looking for. Now, onto my method, and this is my favorite method. For my method, we require a set, just like the bisection method, a set of characters or an array. Also using the range 32 to 126. And an important thing to know is that the closer the character we're looking at is at the beginning of the set, the less amount of requests will be required to retrieve that character. So for this reason, we can arrange our sets by the most common letters in the language. So say for the English language, E is one of the most common letters. So we could position that character maybe at the start of our set. So we map the position of the character and its position in the set, and then what we do is convert this position to binary and retrieve the binary of that position. This way we're effectively reducing the amount of characters to look for from 94 to 2, only zeros and ones. So we can have different sets depending on what we're looking for. Say if we know we're retrieving MD5 hash or password, we can specify a character set that just uses the hexadecimal characters, and this will make it more effective. No matter what the size of the set is, if we have 94 characters in the set or if we have 1,000, it will still be more effective than the binary search, and I'll show you why. This is what the method looks like. Quick implementation. You can see we have our set. That's just the hexadecimal set there. We convert it to the position and convert that position to binary. So say if we're retrieving C, the character C is in the third position in our set. We convert the number 3 to binary, and then which gives us 11. So to retrieve the character, now we just have to retrieve 11. We have to check is it 1 or 0. So essentially, to retrieve the character C, that would take 2 requests. One thing that's important to note is we always start with the first on bit, and for that reason, we always know that the first character or binary digit that we'll retrieve will be a 1. So we can skip that request since we know it will already be a 1, so that saves us 1 request there. But we need an additional request at the end to know that we've reached the end of the binary sequence. So for C, it would be a total of 2 requests if it's in the third position, of course. We could take it a step further and arrange the characters. So the most common letters that start in a word are those there, let's say T. So we could have our set start in that order, and then for retrieving the next character, we can use the digraph to see what would be the most common letter after that one, and always be adapting our set and arranging it in real time as we're retrieving data to have it be more effective. So what's great about this method is that it will only use 1 to 6 requests per character. And I don't know of any other method that's capable of retrieving a character in just 1 request. One of the drawbacks is for my implementation is that we currently require 2 parameter values. And again, I can rewrite it to not have to require 2 parameter values, but it will take a few more requests. But even then, it will still be more effective. So to look at a comparison of these methods, in blue we have my method, red is the bisection, and green the bitwise. To retrieve the character set, we see a 47% improvement. For the MD5, 29% of ABC123. And then for the quick brown fox, at 35%. And it can be a further improvement. It just depends on what characters we're retrieving. But realistically, that's kind of the range. We'll see about 45% improvement. I'll show you a quick demo here. So on the left of the screen, we have the binary to search method, and on the right, we have the regex method. So I'm going to try to run them at the same time. And you can see with my method, to retrieve that hash, it only took 109 requests, as compared to the other method, 184. I'll slow it down so you can see how it looks. It's a quick demo of how we're converting the position to binary and then just retrieving the binary of that position. I also wrote 2 little scripts. I'll be uploading these to GitHub if anyone wants to test them out and try it out. So just to test these methods. So for the binary search, just retrieving the characters A several times. Takes us a total of 114 requests. And we can see that it takes 6 requests for A. Whereas with my method, retrieving A just takes 1 request, considering it's in the first position in my set. So this gives us only 19 requests to retrieve that. And that's closer to an 85% improvement. So now we'll see some queries, further optimized queries, like retrieving all databases, tables, and columns with just 1 request. This is what the query looks like. And I actually have another demo here to show you. So that's just my test page. You can see that it's vulnerable to SQL injection there. Here I go to the SQL injection knowledge base. And it's as simple as just pretty much a copy paste of the method. All I do is add a union there so we can see the data reflected on the page. And there we go. We get all the databases, tables, and columns with a single request. At the bottom, we can see the username and password salt there. So this is a lot more effective than, I mean, you could use other methods like group concat, but that is usually limited by default to 24 characters. With this method, there is no limitations. So I couldn't embed my videos because of different codecs issue that weren't supported. So there are other methods to achieve the same result as the MySQL query we just saw. For example, this one for Microsoft SQL, or Oracle, PostgreSQL. So now I'm going to show you 1 request for remote code execution. What this query does is it will check to see if XP command shell is loaded. If it is enabled, it checks to see if it's active, and then it proceeds to run the dir command in this case, and stores the results in tempdb. That's what the query looks like. And this is possible because with MS SQL we can have multiple queries where other databases don't allow that. And I have another demo for you guys to show you how this works. For this demo, I just ran it in Microsoft SQL Server Management Studio. There you can see a much more organized what the query looks like. So essentially, just running the dir command, and it returns it all in just 1 row. So I'm going to copy and paste that so you can see what it looks like. And there we get all the files. And I mean, right now I'm just showing you in the SQL Management Studio because I didn't have a web page, a web app set up with MS SQL. So here I'm changing it to ipconfig. It's just simple as changing the word. We run it, and the same result. We get the return of our code. So all the times testing can become very tedious. As a penetration tester, I've found web apps that have 400 parameters or several modules with several parameters, and for each SQL injection, we usually have to do at least 3 tests to see if it could be an integer type or no quotations. We could use single quotations or double quotations. So if we had a web app with 400 parameters, for each 3, we'd have to do 1,200 tests. But So I thought, how about if we fuse these together? So this is what it looks like. Instead of doing 3 tests for each kind, I've combined these in just one. So instead of doing 1,200 requests, we can just do the 400, one for each parameter. And to show you how this is broken up, that there is essentially testing no quotations. The hash there is a comment, so it will ignore everything after that. Then we can test double quotations. And the double quotations just includes the single quotations or, so it tests if it's the same. And then single quotations. And this is for or, but there's also ways to do this with anding. And even though we're not really using the keyword and, it has the same logic of testing true or false. So same thing, we have the no quotations, and that's a comment there that just ends it, the double dash. Double quotations, and then the single quotation. So this allows us to save a vast amount of time, which is very important when you're working 12-hour days and you just want to get home to have a beer. This is very helpful. Another reason this is really important too is an attacker could extract the database, the data a lot faster from the database before maybe being detected or blocked. Moving on to obfuscation. I heard a user on Twitter say that firewalls usually have a 30%, mathematically have a 30% error rate or bypass rate. And this is it's comparable to antivirus software. So of course, you know, obfuscation is one of the main tools for, or methods for bypassing firewalls. And so what is obfuscation exactly? I really like this description. It's just the art of making things appear more complicated than they are. I had Elizabeth tell me a story saying that when she tried to explain it to people, she'd say, it's what I did to my parents as a kid so I could go out and party and stuff, you know, just obfuscate the truth. So this is kind of what obfuscation looks like. I'm not going to go into this right now because it'd take me an hour to kind of break it down. That could be a whole separate talk on its own. But I essentially created this query to kind of confuse the admin. The only way they could really know what it does is kind of take several hours to try and break it down and figure out what it was, or they could try running it on their database if they dare. So how can obfuscation be used to bypass firewalls? Here are some tips. It's important to read the documentation and know what the database allows and what's permitted, what's its capabilities, and what it can handle. There are some things, oddities that are documented, and other oddities that aren't documented. And these we can find through fuzzing and other methods. Do you have a question? Sorry, I can't hear you.
I want to send this to my dev team.
Sure. So, another thing is to be creative. A lot of times if you know stuff or can think of a way that maybe the firewall developer didn't know, or features that he wasn't aware of, then there's really no way he can really protect against something he didn't know existed. So for fuzzing, this is a little PHP fuzzer I wrote just to test different white spaces and characters that are allowed in between. In this case, the where 1 equals 1. I just put my, I go through the decimal range 0 to 255 and convert this to the actual character and just insert it into the query and then see if it's accepted or not, if it works or not. So this is kind of what the output looks like. And this allows me to see all the different white spaces that are allowed and other characters that I can put. And this helps us give us a better understanding of what we can use to help us bypass firewalls. I also wrote, when my fuzzer started getting more complicated, I passed it over to Python. And this is just a small snippet of what the code looks like. Essentially the code, I've added more filters and stuff to help me go through the data, because sometimes you'll get millions of rows of data, because when you're fuzzing 4 or 5 bytes at a time. So some of the white spaces I found, say for SQLite. SQLite allows the ordinary kind of expected white spaces. It's got a vertical tab, new line, horizontal tab, normal white space, and so on. With MySQL 5, we get similar, but an additional one is the A0 there, which is like the no break space. And that's one that a lot of firewall developers aren't really aware of, so that can be useful. I decided to test MySQL 3, although it's not as relevant anymore, but it was still interesting to see how it's changed over time. And this is what MySQL 3 allows. Huge range of characters, almost anything in there. And it looks actually funny. I'll show you in a bit what it looks like. So for Postgres, similar to SQLite. Oracle 11, also similar, but there's a really interesting one here, which is 00. Some of you may know this is a null byte. And it's really crazy that it allows a null byte as a white space, because all of applications or software uses this as a terminator, so this could really confuse firewalls and other applications. And finally, we have Microsoft SQL. And similar to SQLite, it allows a huge range of characters. And I'm pretty sure most firewalls developers aren't aware of a lot of these characters too. They will only check for the basic ones. So if we can insert these as white spaces, it will really confuse their firewall and not be able to detect that a SQL injection is malicious, so just see it as normal data. So what does this range of characters look like? Well, that's what it looks like. And that actually works. You don't believe me? There you go, there's a screenshot. So some of the other oddities or interesting things I found through fuzzing, you can see here. A lot of the times firewalls will try and detect union select. So if we can try and combine the union with something else, it might see it might not see it's just union, it will think it's a different word or something. So it's pretty interesting with decimals we can combine the union. Also with an exponent. The TS1 in between the curly brackets, that's an interesting one. The TS just stands for timestamp, but again, it's something that most firewall developers aren't aware of, so it's very useful. And below that, you'll see some odd stuff there. You see the money symbol and backticks with 1.e.t, and that's actually a bug in MySQL's parsing. We can put any number .e dot, and it'll interpret that as just a dot. So that's a very useful, and many developers aren't aware of that. And we can use this essentially anywhere where we'd have a dot, like for the table or the column. MS-SQL also allows joining the keyword with a number if there's a decimal in place. Same with the exponent, we can combine keywords. It also allows what they call an empty hex. So there you can just put 0x and leave it at that, and then we can put the keyword right next to it. That'd be really confusing for firewalls if they're trying to find a hex character and convert that, but then they get a union instead. Okay, this one's really cool. The backslash, it gets interpreted as a 0 for some reason. So we can use it to just combine, again, keywords and make it hard for a firewall to recognize that. For some reason, we can also do select one from together, and that works. Oracle 2 has interesting stuff, like 1F, 1D. I think it stands for decimal. But it's another trick that allows us to combine keywords together. And this was actually showed by Nick Galbraith in his presentation for Libinjection. Libinjection is just a library written in C that helps us detect and prevent SQL injections. And it's funny because he presented this technique in his presentation. And then I tested his libinjection, and that actually bypassed it. So I told him, and he felt a little embarrassed since he had shown it. But it got fixed. Another interesting thing about Oracle is that it's the only database I know where we can kind of fuzz the column names or encode them or obfuscate them. And then again, you can see an example of the null byte being used as white spaces there. Very effective. At some point, firewalls become good at deobfuscating your obfuscation. So in this case, it can sometimes, we can take the opposite approach and try and keep things as simple as possible. The nice thing about SQL is that it has a English-like structure syntax. So in some cases, we can have something that just seems like normal English, and that would be really hard for a firewall to detect. Because a big issue with firewalls will be false positives too. So some bypasses that I have. Mod security. So this was a bypass that I did for the mod security challenge. And in green, I kind of highlighted the important parts of the query that really bypassed the firewall. Instead of using a normal division sign, we used the keyword div. And then those blocks, the hash are comments, which we can use to kind of separate our data. In this case, I had to select 0x00 for it to work. And it detected table name. It was impossible to get a table name in there on its own. So what I had to do was use MySQL specific code, which allows you to specify code to run only if it's, you can specify a version there and only run if it's that version or higher. So there I just put a version, basically version 3. So it will run table name if the version is higher than 3. So again, by allowing me to combine table name with something next to it, mod security wasn't able to recognize the keyword table name. This is this has been fixed already. I've been working with Ryan Barnett, helping improve mod security. Currently, this works using case, when, binary, true, and so on. However, it's almost impossible to get a union select in there. And this is an issue known as the union select matrices. Someone tweeted about it, and then Nick Galbraith wrote a blog about it. And the issue is that almost all firewalls will detect union select matrices as a SQL injection when it's not really a SQL injection. So something that firewalls have a lot of trouble with is fighting these false positives, trying to detect SQL injections but allow valid data to go through at the same time. I wasn't happy not having a union select bypass, so I stayed up kind of late last night working on it. And this is what I came up with. The mod keyword was essential there to get by. Again, using the decimal, I was able to unite the union with the 2 there. So that allowed it to not recognize that union properly. And then using the no break spacing between the union select didn't allow it to really see that union select there. And you can go to, mod security has several test pages. Right now it's just, one of them, the one I tested was the Acunetics page. They have a little demo set up which just proxies through it, and you can try that out and it'll work. I was doing a job for a client and I noticed that this worked. And I later found out there was Fortinet that was behind it and it was allowing that to work. Essentially any character above the range 80 hex or 80, will go through. So we can put FF in between the select or any keyword and it just removes it, so that works and the firewall doesn't see that. Green SQL was an open source firewall. It then went commercial. When I was testing it out, setting it up, at first I thought I hadn't set it up properly because I couldn't get it to detect my SQL injections. I later found out that it was set up properly, it just wasn't detecting my SQL injections. That first one, union select table name from information schema out of tables, limit 1. No obfuscation to it, it wasn't being detected. So I actually had a meeting with Green SQL to see if there was anything I was doing wrong, and they said that's a bug that should be detected, so they'll fix that. It seems to really detect SQL tautology. So if I added a 1 equals 0 there, that gets detected. But it's really easy to bypass that, just adding an exponent like 1 equals 0 dot exponent 1. That doesn't get detected. Or the binary keyword is really cool. It helps bypass a lot of firewalls. We can put the binary keyword right before what we're selecting. So the column name, or in this case just 1. And all firewalls don't expect that you can have a word right before the 1. So that also bypasses their detection. And so I didn't really try that much because it was too easy, but the last one, I'm just using an if, that totally goes undetected too. But they're really helpful, and Green SQL does have a lot of other solutions and security on the database, not only the detection, so that might be worth checking out. Also, when I was testing the software, I decided to try a simple cross-site script in the comment box. No bueno. I mean, out of all places, the comment box is kind of the most obvious place where you'd be able to, I mean, they should secure against cross-site scripting or something like that. And it worked. I didn't test anything else, so I don't know, but just something to be aware of. So lib injection is really good. It's, like I said, written in C, and it doesn't use rejects, it uses tokens. And what's really great about it is that it's fast. It's really fast compared to using regular expressions. This is kind of funny. These are all bypasses that I had reported to Nick, and he had fixed them. But then comes the issue with false positives. You try to fix false positives, and then you reintroduce other SQL injections that were fixed before. So the first one is a really simple one. All I did was add an alias there, in that case websec. A lot of times people think you have to have as before for it to be an alias, but you don't have to. You can just put it right after the column. And that works. Using a new line between the union select works as well. That Oracle issue where you can put the F with the union, if there's a number that he had presented and fixed, got reintroduced again. So again, that's another bypass. It still doesn't check really for other statements. In Microsoft SQL, like we can add different queries out there and it won't detect it. And then again, we can use the curly brackets or the square brackets, and that goes undetected as well. So these are ones that currently work, but I've literally come up with hundreds of bypasses for lib injection. So here are just some other ones that I found interesting. These have been fixed already though, but just something to think of for when you're testing other firewalls. That last one there, the procedure analyst, that's kind of cool because you can put invalid data in the brackets or in the parentheses, and it's as long as you have a union select after, it won't run the procedure analyst. So you can just put invalid data there and it'll be fine as long as you have a union select after. Next up, we'll see some encoding methods, and these encodings aren't really specific to SQL injections. It can be used to bypass anything like, say, cross-site scripting or whatever you're after. And the thing about these encodings is it depends on the application or how the data gets transformed and processed, and by several layers. It could be the firewall, it could be the application, there could be a proxy in between, and they'll all kind of read the data differently or handle the data differently. So we can use encodings to bypass firewalls in some cases. The most basic one is just a Euro encode. Everyone's pretty familiar with this if you've ever navigated in the web browser. When you type special characters in the web browser, they get transformed to a Euro encoded version. And basically, it's just a hexadecimal version of the character prefixed by a % sign. Similar to the Euro encode, we have double Euro encode. If the application does a decode on the data, we can double encode it, basically encode the % sign, which is just 25, and now add it in front. So when it decodes that once, we'll end up with the % 61, and when it decodes it again, then we'll get the character. I contributed a lot of tamper scripts to SQL map. And what a tamper script is, it basically transforms the request that you're sending in a way that will hopefully bypass a firewall. So care encode is one I submitted that just basically does a simple Euro encode. And the description they put there is useful to bypass very weak web application firewalls. They didn't believe me they would bypass anything. I told them, trust me, it does. So they decided to include it, and I'll show you a demo. So I try to access hakim.ws, and that gets blocked as hacking, the category. This is an iRimport firewall, by the way. So all I have to do is Euro encode one of the characters in the host header. So when it gets sent, it doesn't get detected as that web page. So I read on Wikipedia that Cisco bought iRimport in 2007 for around $830 million. So it's kind of funny that something as simple as this would work. So just changing the hosts, one character in the host, you're encoding it, we're able to access the whole website. So that's a content filter bypass there. And I tried double Euro encode, and that also works. Unicode is another encoding that usually works with IIS. And essentially it's just adding a U00 and then the hex version of the character. UTF multi-byte encoding is kind of an interesting one. And essentially what it does is the leading bits of the first byte will indicate how many sequential bytes are after that, up to the first 0. And then after that, the following bits of the second byte will always start with 10, and then the rest of it will be the data. So, for example, with two byte sequence UTF encoding, the first bits up to the first 0 shows us how many following bytes are there, and then for each following byte we always start with 10. But that's kind of redundant since we already know how many bytes are following. We don't really need that 10. So some applications might not read that 10 and just read the rest. So this allows us to give us different variations for the same 2-byte encoding or sequence. So the first 2 high order bits would be 10, 0, 0, 0, 1, and that's how each variation looks. So it's worth trying all of them and see which one works. Nibble encoding is another interesting one. A nibble is just 4 bits. And so essentially, a nibble can represent any character in a hex, or 2 nibbles that form an octet. So there you can just see how each character can be represented in a nibble, or 4 bits. And so we start with first nibble encoding, where we just essentially re-encode the first character of the hex. So in this case, A, which equals 61, we just encode the 6 only, which equals 36. So then we end up with %36 1. So if it were to decode the first nibble, then that would turn out to be the character we want. It would bypass. Second nibble encoding is similar, but instead of doing the first nibble, we're encoding the second nibble. And it's just a Euro encode that we're doing. Then we get double nibble encoding, and this is a combination of the first and second nibble encoding, where we just encode the first nibble and then the second nibble. Essentially what it looks like. This is a really cool one, invalid % encoding. This works with ASP, and basically we can put % signs in between characters and it'll remove them. And this works with a lot of firewalls. I think this bypasses iRimport actually, and several others. And we can actually have multiple just % signs followed by each other, and it'll run fine. It'll work. Invalid hex. This is another interesting one. Essentially, if application converts the data into decimal, what we can do is create invalid hex that results in the same decimal value as valid hex. For example, in that table, we can see how invalid hex, instead of stopping at 0F and then moving on to 10, it would continue on to 0G and then 0H and so on. But when we convert that to decimal, we end up with the same result, in this case 97. So again, all these depend on how the application will handle the data and what it does with it. These may work. On to Leapfrog. As I was saying, Leapfrog is a tool that I'm developing to help test firewalls, find bypasses, and provide solutions to these bypasses. Currently, it's just working for SQL injections right now, but eventually I'd like to add local file inclusions, cross-site scripting, content filter, and really make it a complete tool to cover all types of firewalls. The cool thing about it is it creates all its bypasses dynamically on runtime and tests these bypasses. And then it provides recommendations for successful bypasses. And what it does is it uses a WAF acceptance factor, which is a score of how many vectors were allowed through. I got that term from Wikipedia, the WAF acceptance factor, which is essentially how nice a product is, or how much convincing you need, how much you need to convince your wife, to get a product and such. For the demo, I just have a screenshot. So it tests the string, finds the string, it moves on to testing encodings, because that's kind of the first thing we'd want to test. After testing encodings, it will tell you what encodings are available to use, and then it will try to use those encodings. It will also test different terminators, so things we can use to end queries and such. So in this case, it determines that the injection is of type integer, and it uses a simple arithmetic bypass to determine that. It proceeds to test different keywords, and this is kind of an old screenshot. I should have updated it with new data. But I'll be making this tool available on my GitHub as well. As well as all the code that you've seen, I'll put it on my GitHub so you guys can check it out. And that's it.